Alright, so the last section of this chapter talks about spheres, basically a ball, and the surface area of it. Now the one issue with this compared to every other shape is that there's no flat surface. We were able to open up every other shape into a net and make it a flat surface. This is the one that we are not able to do that for. So for a sphere, it's a locus of points, a group of points that are a certain distance away from one center. Okay, a circle is a 2D version of a sphere. A sphere is go in every direction the same distance from a center. So there still is a radius. It still is the distance from the surface of the sphere to the center. The diameter of a sphere is a chord that contains the center. So from one end of the sphere through the shape to the other and crossing exactly at the center. And then a chord of a sphere is a segment whose endpoints are on the sphere. So any line going through the sphere. A great circle is the circle that has the center that is exactly the center of the circle. So the circle here has the circle, or has the center that the sphere also has. Because I could draw a circle if I slice the sphere up here, but it doesn't have the same center. What that does is splitting this creates two hemispheres. So on the Earth, we have a sphere. This great circle is the equator. It's the line going through the exact center of the circle, or of the sphere. So Archimedes was a mathematician a long time ago, and he discovered that a cylinder and a sphere have something in common. That if I take the lateral area of a cylinder and I take just the lateral area and I cut it up and kind of piece it together, it is the surface area of a sphere. So the lateral area of the cylinder is 2 pi r times the height. So that's 2 pi r, and then the height is actually 2r. So we multiply by that. So the lateral area became 4 pi r squared. So the area of the sphere, surface area of a sphere, is 4 pi r squared. We can relate the surface area of a sphere to being just a rectangle that is 2 pi r by 2r. So let's go ahead and start working with this formula. We're going to use that formula every single time. Find the surface area of this sphere. Because the diameter is 32, r is 16. Surface area is 4 pi r squared. So 16 squared gets you 256. We're going to multiply that by 4. So our surface area is 1024 pi, because it has a pi at the end. Find the surface area of a sphere with an area of a great circle of 81 pi square feet. So the great circle is just a circle. That's pi r squared. So 81 pi equals pi r squared. Oh, that's messy. Let's rewrite that. 81 pi equals pi r squared. That's not much better. Pi's cancel out. 81 equals r squared. R is 9. Now that r is 9, if the radius of the great circle is 9, the radius of the sphere is 9. So my total surface area is 4 pi 9 squared. 9 squared is 81. Multiplied by 4, I get 324 pi. So that's really the only two ways we can do stuff for spheres. We're going to add in hemispheres. So on a hemisphere, the difference is you sliced it in half, you've created a flat surface. So the total surface area has a lateral area now plus one base. The lateral area, it's half of a sphere. 4 pi r squared over 2 because it's half, and then pi r squared because the base is a circle now. 4 and 2 cancel out. I get 2 pi r squared plus pi r squared. So you could think of it this way as lateral area plus the base, or we could think of it as adding these two together because they are both pi r squareds and giving 3 pi r squared. So, total surface area of a hemisphere. I'm going to do it this way, 2 pi r squared plus pi r squared. I'm going to think of it as lateral area plus a base. The great circle has a radius of 8 yards. So we got 8 right here. So 2 pi 8 squared plus pi 8 squared. I know I'm doing more work doing it this way, but 8 squared is 64 times 2 gets me 128 pi. So the lateral area of the hemisphere is 128 pi. The base is 64 pi. So let's add them together because they both have pi's. The total surface area is 192 pi. Next one, the surface area of a sphere is 144 pi square yards. Find the radius. So we're going backwards here. Surface area is 144 pi. Surface area is also 4 pi r squared. So let's cancel out our pi's. Got 144 equals 4 r squared. Divide 144 by 4. You get 36. And opposite of squaring something is taking a square root. So r is 6. And our last example, we've got a hemisphere on top of a cylinder. Okay, so I need, for my total surface area, we're going to break this apart as much as possible. We have a hemisphere plus a cylinder. So for the hemisphere, and this is why I wrote it separate here, I need only this part of the hemisphere. The reason is the hemisphere is on top of the cylinder, so the top base of the cylinder and the bottom base of the hemisphere are not actually on the surface anymore. They're inside the shape. So I only need the top part of the hemisphere, 2 pi r squared, plus for the cylinder, so that's just for the hemisphere. For the cylinder, I have one base, pi r squared, the one on the bottom, plus 2 pi rh, which is my lateral area of the cylinder. Let's go ahead and plug everything in. We know r is 5 because the diameter is 10. 2 pi 5 squared, so that's for the hemisphere. The base of the cylinder, the one base, remember we're not doing the top base, plus 2 pi r, and then h is, h is 6. So let's plug that in. So 5 squared is 25 times 2, 50 pi for the hemisphere, 25 pi for the base of the cylinder, plus 60 pi for the lateral area of the cylinder. We're going to add all these together. 135 pi is our total surface area.